Hello, welcome back. This video covers section 10.3, which is slope of a line and rate of change. Introduction to the slope. The slope of a line is the ratio of vertical change, which would be in y, between 2 points and the horizontal change in x. Think of slope of a line as rise over run. I also like to think about slope as if I was running and sometimes I run uphill and it's kind of difficult, and that would be a positive slope. Sometimes I run downhill and that would be a negative slope. Anyways, slope can be thought of as the change in y over the change in x, which we can also say is rise over run. So the change of rise over the change of run. And so for this number one, it says determine the slope of the ramp. And I'm sorry that it's missing a little bit of information. So actually, this should be 5 feet, and this is supposed to be 15 feet. So I apologize, it got kind of displaced. So to find the slope, so the slope is the change in y over the change in x. And so the change in the y would be 5 feet, and the change in the x would be 15 feet. So the rise is 5 and the run is 15. And 5 over 15 reduces to 1/3. So the slope is 1/3. All right. There is a really nice handy formula called the slope formula. So the slope formula is denoted by m. Slope is m. So anytime you see m, you should think slope. The slope of a line passing through the points x1, y1, and x2, y2 is m is equal to y2 minus y1 over x2 minus x1, where x2 minus x1 cannot equal 0. It would be undefined if that happened. So we're going to do some of these together. So it says find the slope of the line through the points -1, -4, and -5, -5. So one thing I would have you do is label your first ordered pair x1, y1, and let's label the second ordered pair x2, y2. And then what we'll do is we're just going to use the formula and we're going to replace those values. So my y values are going to go in the numerator and my x values are going to go in the denominator. So here are my y values. So I'm going to have, and also I would suggest going ahead and putting minuses for the formula. And then I'm going to do this in red for my y's. So y2 is -5 minus y1, which is -4, over x2, which is -5, minus x1, which is -1. Now, if you're very careful, you can type this whole thing into your calculator, especially if you have the fraction key. You can type it all in. If you wanted to try it by hand, then would become positive, and it would be -5 plus 4, which is -1. And then the same thing, these double negatives would become a positive. It would be -5 plus 1, which is -4, and a negative over a negative becomes positive. So this would become positive 1/4. But you can verify that with your calculator. So you can actually type it into your calculator here using the negative symbol and the minus symbol as well. All right, let's try number 3. Find the slope of the line through the points 4, 6 and -3, 6. So we've got x1, y1, x2, y2. We're going to use our slope formula again. And I'm just going to kind of write it as minus and minus on the top and bottom. And now I'm going to plug in my values. So I've got y2, which is 6, minus y1, which is 6. And then I'll do the x's in blue. So then I have -3 minus 4. Okay, so this is what it looks like. So I end up with, if I type this into my calculator, I'm going to directly get 0. But if I try to work this out, 6 minus 6 is 0, and then -3 minus 4 is -7. 0 over -7 is 0. So this has a slope of 0. And so sometimes if you get a 0 in your top part, in your numerator, then you're going to end up with a slope of 0. So m equals 0 here, and m was equal to 1/4 up there. All right, let's try another one. so this next one says, find the slope of the line through the points 4, 6 and 4, 9. So I'm going to have x1, y1, x2, y2, and then m is equal to y2 minus y1 over x2 minus x1. All right, so I've got my skeleton set up, ready to go. Now I'm going to go ahead and plug in my values. All right, so I'm going to go ahead and do the y values in red, and I'm going to do the x values in blue. So once again, my y value is going to be y2, which is 9, minus y1, which is 6. And then I'll do 4 minus 4 for my x values. Okay, now if you type this into your calculator, it's really fun. If you type that into your calculator, you might get undefined or cannot divide by 0, or your calculator might just explode or something. Not really, but 0 is in the denominator. Okay, that's impossible. So when this happens, that slope is undefined. Okay, so when this happens, we have what we call an undefined slope. Sometimes that does occur, all right? And that actually leads me to my next point. So graphically, this is what happens. An undefined slope would look like this, right? It would be a vertical line. So vertical lines have an undefined slope. The 0 slope is the perfect running slope, right? If you think about a track is flat for a reason. A positive slope would be like running uphill, and then a negative slope would be like running downhill. Okay, so those are the 4 different types of slope that we can actually have. All right. Okay, so we're going to do a few more problems with some applications of slope, because you actually see slope in the real world pretty often. So it says, a vendor has learned that by pricing hot dogs at $1.25, sales will reach 123 hot dogs per day. Raising the price to $1.75 will cause the sales to fall 101 hot dogs per day. Let Y be the number of hot dogs the vendor sells of X dollars. Find the slope of the linear equation. All right, so we have some ordered pairs in disguise. So I would say first, let's create some ordered pairs based on the situation. So one ordered pair can be from the first sentence I read. So $1.25 would make 123 hot dogs for sale, or they sold that many. And then the other ordered pair we could use would be from the next sentence, $1.75, they sold 101 hot dogs. Okay, now we can let this be x1, y1, x2, y2, and then we can use our formula. M is equal to y2 minus y1 over x2 minus x1, and I can just plug my values in, right? So I will do that. I'll have 123 minus 101 on the top, and then on the bottom will be my x2 minus x1, so 1.75 minus 1.25, and when I work that out, I end up with negative 44. And so if you think about what does that mean? Well, the fact that I have a negative slope means that the vendor sells 44 less hot dogs. So for every dollar increase in price, the vendor sells 44 fewer hot dogs. All right. So here's another equation. It says the linear equation y equals negative 44x plus 176 models the number of hot dogs sold per day when the price x is x dollars each. Find the number of hot dogs sold when the price is $1.50. All right, so if y represents the number of hot dogs, and then the sold per day when the price is x. Okay, so x is our price. And in this case, they're saying $1.50. So we need to use our equation, but we're going to replace x with $1.50. So it's going to be negative 44 times $1.50 plus 176. Okay, so this would be what I would type into my calculator. And when I do this, I end up with 110. So y equals 110. So that would be 110 hot dogs. Okay, it says, according to your model, how many hot dogs would the vendor sell if the price was $4 each? Wow, okay, $4. So if the price was $4, we're going to plug $4 in for X. And so all of that would be ready to go into my calculator. And I end up with 0. Ooh, no, that wouldn't be good. So that would mean 0 hot dogs. They price them so high, nobody's going to buy them. All right, I hope this video helps. I hope you have a great day. Bye.